this video we will go through 2023 paper 2 question 2. Okay, this is a question on Newton's laws of motion. Okay, so it is an interesting one and it might look a bit strange in the beginning, right? But I hope that after this video you can see that you just follow through with your normal concepts, okay, and you should be able to do okay. Right, okay, so now for the part A, right, okay, we are to draw and label the forces that act on the man, right, okay, so after you have read through carefully, you will see that figure 2.1, this is on the Earth's surface, where there is a gravitational field acting on the man, okay, so therefore, right, okay, this we can still proceed as we usually do, okay, that we will have an arrow. Draw a straight arrow coming down. Okay, and this, you label it as the weight. Okay, or you can also label it as gravitational force. Both are okay. Okay. Now the man is standing in the lift, so the floor of the lift is supporting the man. So that would be a normal force, okay, on the man. So you can either write normal force or normal reaction force. Both are okay. Right. Okay. So that one will be for figure 2.1. Okay, now on figure 2.2, this is for the man who is at a region where there is no gravitational field. Okay, so which means that there isn't any gravitational field force like the G that per se. Okay, but the man is accelerating upwards. Right, the man is accelerating upwards. Okay, so he does have therefore a net force acting on him because he is accelerating. Okay, so in this case, okay, let's think about how possibly that he can be accelerating, moving upwards, right? Okay, so in order to move upwards, it must be because of the floor of the lift is pushing him upwards, right? Okay, so therefore, in this case, the force that is acting on the man is just the normal force, right, by the floor of the lift acting on him. Okay, so that will be the answer for part A. Okay, so part B, state what causes the forces acting on the man in the two figures. Okay, so here this is about what causes the force, right? Okay, and notice it is 2 marks only, so 1 mark for explaining the cause of each of the force. So here, therefore, we are not looking, the question is not looking for an explanation of how, right, the forces come about, or why, you know, the forces is a certain value as such. Okay, therefore not requiring you to apply Newton's laws first, because if you look further on, you can also see that Newton's laws of motion is required in part C. So part B, you do not need to invoke Newton's laws of motion first. Right, okay, so for part B, what they are looking for is, example, the first force, which is the weight, okay, or gravitational force. So what causes this force? Right, okay, so the answer, to answer such a question, right, in the most straightforward manner, you would just be required to say that it is the weight is the gravitational force by Earth on the man. Alright, okay, so okay, therefore moving on to just show you the answer. Right, okay, so this part B just needs you to say weight is caused by this, right, gravitational pull by Earth on the man, and the other force, the normal force, right, okay, is caused by the contact force, okay, by the floor supporting the man. Alright, okay, so this is just what is needed for the second part, that's all. Let me paste that in. Paste. Okay, I might show you this one. Alright, okay, so this is the answer that part B is looking for, that is all. Right, okay, so now moving on, the last part, use Newton's laws of motion to explain why the outward force on the man in figure 2.1 is equal to the outward force on the man in figure 2.2. So interpret the question first, break down the question first, right? Okay, so don't rush into answering, but take some time to digest and interpret the question first, right? Okay, so here the question requirement or the task for you is to explain, okay, why this thing so big, right? Okay, to explain why, okay, outward force on the man in figure 2.1 is equal to the outward force on the man in figure 2.2. Alright, okay, so since we already have the actually the free body diagram, right? Okay, in this part on the man, okay, so we can see that the upward force that the question part C is referring to is this one and this one, right? The normal force exerted on the man due to the floor supporting him, right? Okay, so the task therefore for you is what is the value therefore of this normal force, and the value of this normal force will work out to be the same, okay, in value for this normal force in the second diagram, okay, and you are going to use Newton's law to give explanation for that. Alright, okay, so before you jump into writing out your answers, okay, in the lines, use a pencil or whatever, right? Okay, use the empty space, anywhere, right? Okay, and you plan, right? Okay, your answers first. You think through first. Okay, so now let's think through figure 2.1. Figure 2.1, read again. It says it shows a man in a stationary lift. Okay, stationary, what does that mean? Okay, so if you look at the revision video, right? Okay, whenever object is stationary, okay, this is a cue word for us to let us know that, okay, we can apply Newton's first law, right? Okay, which says that the net force on the object must be 0, right? Okay, so therefore, the forces all must counterbalance each other, right, in opposite directions. So in the first case, if I have one upward force, one downward force, okay, then it would mean that, all right, okay, so this is a draft of the answer. Okay, in figure 2.1, okay, since net force is 0, okay, then it would mean that the normal force must be equal in magnitude to the weight. Okay, and since this is on Earth's surface, right, okay, then the weight is given by m times g, okay, where g is the gravitational field strength, okay, of the Earth, right? So linking these two relationships together, linking this and this together, okay, then it brings us to realize that magnitude of the normal force must be equal to mg. Okay, now, okay, so we put that aside first and think about this situation in figure 2.2. Figure 2.2, guy is accelerating upwards with acceleration g, right, okay, of a value g, right, okay, and this g is also gravitational field strength, okay, of the Earth, right? Okay, so now accelerating, okay, which law to use, right? Okay, so here, remember your Newton's law, right? Whenever object has acceleration, it is time for us to invoke Newton's second law, where net force is given by product ma. Okay, so here, therefore, okay, looking at the situation, draft a little bit again. Okay, so on the guy, net force is equals to ma, okay, and the expression for the net force, okay, we realize that there is only one single force acting on the man, so the expression for the net force must therefore be just n. There's no other forces to form any combination, right? Okay, so therefore it is just n. And then the other side of the equation, okay, product ma, right? Okay, so mass of the man don't change, but acceleration, right? Acceleration, they gave us that it is just equal to g. So substitute your a, right? Okay, by g, you will see that n therefore is given by a magnitude of mg, right? Okay, so both sides will end up with magnitude of mg. So this is what part C wants you to explain, right? Okay, that is all. Okay. Okay, so therefore writing it out in a more nicer prose form, okay, I will write it this way. Okay, so in figure 2.1, since man is stationary by this law, okay, because need to show use, okay, the resultant force acting on the man is 0. Okay, so here I'm showing my application of Newton's first law. So the upwards normal force must be equal to the downwards normal force of this magnitude mg. Okay, now in figure 2.2, since man is accelerating outwards, then by Newton's second law, resultant force equals to ma, and since resultant force is only the upwards normal force, it is equal to mg and ma, and since a equals to g, and therefore normal force is also mg in magnitude. Alright, okay, so and this question is done.